So mainly we have to understand what is a vector. So what is a vector? So vector is a quantity which has a magnitude and a direction. So magnitude means value. Right? So it has a direction. Like for example, $5 has a value. That's called the magnitude, but doesn't have a direction. Right? So what is a scalar then? Scalar has a magnitude only. Okay. Example for this one: magnitude, mass, distance, speed. What else? So many things you can make as a magnitude only. But magnitude plus direction. So you can think velocity and speed, two different. Then you can say displacement. Displacement and distance are different. Right? Force has a direction and a magnitude. So likewise you can describe. So we have vectors and scalars. Right? Okay. Now, if you think about a vector, this vector has a magnitude and multiplied with a direction. Right? So magnitude multiplied with a direction. Example, I'm going to make example. Magnitude I'm going to give 5. Direction I'm going to give north. In between you have multiplication. So then 5 north, you understand magnitude and direction. So you're going to give a notation here. I would say V. To say it's a vector, you put arrow. Right? So it's a vector now. Right? So always vector is nothing but magnitude times direction. Right? Okay. Now let's think about what vectors can do. Properties. First one. If you consider a vector in this direction, like this, which is B, right? This is B. So I'm going to have a small vector over here, which is parallel to the previous one. And I'm going to say this is lambda B. Now what has happened? V is a vector. The size of that is this much. Direction is that way. Now I multiplied with that by a lambda. So indeed you can understand lambda is less than 1. Lambda is less than 1, that's why it is smaller. If I'm going to make a bigger one, so you can see this is bigger than, the size is bigger than the original V. So I'm going to write this one as gamma V. So in this case, gamma is greater than 1. If gamma is equal to 1, that is going to be B. Right? Also we have to understand all of these are parallel. Reason? We are using the same vector here. Because that vector has a specific direction and that should be parallel. So what you are going to do is, you are not going to touch the direction, but you are going to alter the size through this lambda or gamma. Okay, so that part is fine. Now, second one, vectors can parallelly translate. Right? like X translation, Y translation. So what do you mean by that? Suppose there is a vector here. Suppose this vector name is P vector, right? So the position of the vector can be changed. So I'm going to move this to here and here, like this. Still it is P vector. So this is parallelly moved. This is parallelly moved here. Direction, no harm, same direction. See, parallelly moved. All good. So likewise, if you want, you can move that to somewhere else as well, like here. Somewhere else. The only criteria is it should be parallel and the size should be the same. So we can parallelly transform. Right? Example. Suppose you have something like this. Suppose you have u vector here. You are going to have a v vector here. Right? So they are sort of separate right now. Now if you want to, you can bring this guy in here. This one you can place on here and make it like that. Why? Because it can be parallel transformed. Or this one you can put it here. Depends on the situation, your necessity. Right? So what I'm saying, this you can bring here. If that happens, it looks like this. See, still it is V. Right? So this is the parallel transformation. Right? Okay. Then next one is vector triangle. Vector triangle. Vector triangle is this. Or you can say this vector addition. Right? So vector addition means, suppose you have a vector here u, starting from this point A, and then goes to B, and from B you have another vector here, and suppose this is B, right? So starting position is A, end position is C, final position is Z. So this journey is like, you're going from here to here and here to here. That means what has happened as a resultant? It has gone from here to here. What has happened is that, right? So this one, AC vector, you can represent as u plus v. That is called vector addition. That is called vector addition. Now if you think about a triangle, suppose this is a triangle, right? Suppose this is 5, this is 6 size. I'm not saying the length of this one is 11. I'm not saying that. Lengths are not going to be the same. But vectorially, you can add it like that. This is called vector addition. Right? So, example. You're starting from here, I would say. It goes here, U, and then from here it goes here, V. From here it goes here, W, and this is your final. You're going to stop on there. Now what would be the resultant vector? Resultant vector would be from here to here, initial to final. This vector. I would say this is R vector. Now that R vector is nothing but U plus V plus W. Yes. So what I'm saying finally, there is a thing called vector addition. Vector addition. Right? There is nothing called scale addition. Right? There is nothing called scale addition. Now we'll discuss a couple of examples so that we can understand this better. Suppose I'm going to have a vector from this O, this is a point, Simple A. So this is a vector, right? I'm going to have another one. B. Okay, like that. Now you have to understand why both of the vectors are starting from here. Why both of the vectors are starting from here? Actually not. So suppose this vector is somewhere here, like this. But you know, with parallel transformation, you can bring it to this point. That is what is happening. Right? Somehow you got it. That's the idea, okay? Now you got that. Now you need to calculate. I'm going to make this vector. You need to calculate AB vector. Now, this has a specific direction, right? Why? Because A point is a fixed point, B point is a fixed point. If you make an arrow, that has a specific direction and that has a specific distance as well. So it's a vector. Suppose this vector is AB vector. So I would say C vector. C vector or AB vector. Doesn't matter. These are notations. Now, you tell me how to find Z vector. You need to find them. So A and B is given to you. This is very easy. Now we understood vector addition, right? What is vector addition? Vector addition means you start from here, you go here, you go there, you go there. Finally, what happened? Initial to final, see? Right? We use this one. If you start from here, you can use any pathway. You start from here, you go here. Then again you go here. It is similar to you are going from here to here. So the vector addition tells you this plus this is equal to this. So that means you can say A plus C vector. Vector addition should be is equal to, because this is initial, then this is final at P. Should be is equal to P. Yeah, so this is vector addition. Right? So C vector you can find. Bring A to the other side. P minus. So that's how you find an unknown vector using vector addition concept. All good? Let's think about another one. You have a vector from here to here. This is O, this is A, this is B. So I'm going to say this is a simple A vector. I'm going to say this guy is B vector, for example. Right? So I'm going to make few points here. 1, 2, and 3. So I have 3 vectors here now. So I would say this is P point, Q point, that is B point anyway. So you need to find OP, OQ, OB, those vectors you need to find. What is given here? B vector and A vector only given to you. Right? But it should be given to you that the locations of this. So it is given to you AQ is equal to half of AB. Given details. Right? Then AP distance is equal to 1/3 of AP. You get what I'm saying? So these are distances, okay? I'm talking about distances. Right? Now what we know? AB is B. So we know AP. AP is going to be 1/3, right? 1/3 of AB, right? So that's going to be 1/3 of B vector. Because size is 1/3 now. Direction has no effect. What about AQ? This vector. AQ is half, so it's going to be half of P vector. Right? So now, suppose you need to find OP vector, right? Can I do this? If you want to find this vector plus this small part is equal to this vector. Easy, eh? So I'm going to write OP vector is equal to OA plus AP. This is again vector addition. So OA is a AP. AP is 1/3. So similarly, you can find OQ. So I'm going to write here. OQ is OA plus AQ. So this is A. AQ is half B. Right? Then you need to find OB. OB is nothing but OA plus AB. So this is A, AB is B. So those are the values. So now we understood a couple of properties, right? So third one is the vector addition, right? Fourth one, so we have to think about negative vectors. Negative vectors. So suppose this vector is a vector. If you want to change the direction, that means same vector, you want to change the direction to the other way, that's going to be negative. That's it. So now vector subtraction means you are introducing a negative vector. You are changing the direction. Yeah. Okay. Example. So A, O, A, B. So I'm going to say this is A, and I'm going to say this is B. So I need to find AB, yeah? So AB vector is what? AB vector is OA plus AB is equal to OB, yeah? So this should be B minus A, okay? Yeah. Suppose you need to find BA vector. What is BA vector? Reverse, right? It's going to be minus AB. So it's going to be A minus B. Okay. Let's do another question. Think about so this is B vector, this entire thing is A vector. This is a perpendicular bisector. Right? Perpendicular bisector. And I'm going to get a point over here. So this point I would say this is C, this is P, right? So I'm going to say CP distance is going to be 1/3 of BP distance. So that means this one is 1/3 of 1/3 of actually 1/3 of BC. 1/3 of BC vector, right? So this one is 1/3 of this one. So we'll try to find out whatever we can. Now you can see BA vector. What is BA vector? No? Vector addition. So BA vector is this way, right? So you understand this one plus that guy is going to be this guy, right? So you can say actually B vector plus BA vector is equal to OA vector, no? See? Okay, so this plus this is equal to this. Yeah, so why I choose this one? Because of this arrow here in that direction, so it's convenient. Otherwise I can do this way, so this is going to be minus A vector then, plus this one, then B vector, and there is this one. Yeah, still can do, right? Okay, what I want to say, BA vector. So BA vector is A vector minus B vector. Yeah, BA is equal to A minus B. Okay, we found it. What about BC? BC is equal to C minus B. Is that right? That's not right. That's not right. So you have to understand BC here. This one you can find from here. OB plus BC is equal to this guy, OC. What is OC now? What is OC now? You have to understand OC is the half of OA. Yeah? Okay, use that. Half of OA. Very easy. So OA is how much? OA is A. So half of A. Done. So now vector addition is what I'm going to do. So vector addition is OB plus BC is equal to OC. Right? So you need to find BC now. So I'm going to subject BC here. So that's going to be OC minus OB. Yeah. So what is OC now? OC we have here, half A. Half A minus OB. What is OB? That's it. That's how you find BC. Pretty easy. Now you need to find, suppose BP. Suppose you need to find BP. From here, you know? What is BP? BP is 2/3 of BC. Na? It is given to you here. So you can say BP vector is nothing but 2/3 of BC. Yeah. So it is going to be now 2/3 of BC. How much is BC now? BC is over here. It's going to be half of A minus B. Just a matter of substituting it. Done. So what about PC? PC is 1/3 of BC now. Right? So now this is now 1/3 of, how much is BC now? Again, the same thing. Minus B. A vector minus B vector. Yeah, proceed. Okay, think about the same question but given in this way. So let me draw this one for you. So if I draw this, so it would be like this, right? So what we have is OA vector is given to you as A, OB vector is given to you as B. This is a perpendicular bisector. This is a perpendicular bisector, for example. Right? So now you can take this point as P, this point as Q, this point as R, for example. Yeah. So now you understand AB vector is B minus A. You know that. Then let's think about AP vector. AP vector, half of that, right? Half of AP. So it's going to be half of B minus A. Half of B minus A. Then PB vector. So PB vector is the same, right? PB vector is the same. Why PB vector is the same? I told you. This vector, size-wise, is equal to this vector. Because half and half, right? Direction also the same. What if you translate this and then copy and paste here? You get it, right? See? So they're the same. Okay? All good. So now we know AP, we know PB. Okay. So now let's think about OQ and QB. OQ. OQ is half of B, yeah? Half of B, and that is equal to QB as well. Correct? What I'm saying, this one is equal to this one. Okay. So now, what we can do now, do you know how much is this one? No. And in the previous question, it was given 1/3. Do you know how much of this one? No. In the previous question, previous question we didn't have it. But if it is given, that's easy. It is not given. So what we are going to do, is this. Let AR vector is equal to lambda times AQ vector. Lambda times AQ vector. Yeah. Now you understand lambda is less than 1. Right? Okay. So what is AQ vector now? We don't have AQ vector yet, yeah? Okay. So let's find AQ vector here. What is AQ vector? So you know that AQ, OA plus, okay, let me write it with all the informations. OA plus AQ is going to be OQ, right? So you can find AQ here. AQ is equal to OQ. How much is OQ now? OQ is half times B vector, right? Then minus OA vector is A vector. So that is AQ. So once we have AQ there, so you can substitute it here. Then what you're going to get is lambda times AQ is going to be half V minus A. That is AR. Pretty easy. Now, next one is, so we got this one. We got this guy. We got this guy, and that is AR. Right? Now, let OR. Let OR is equal to gamma OP. Gamma OP. Right? Makes sense. What is OP? We have to find. So OP is this. So I'm going to use this plus this is equal to this. Vector addition. It's all vector addition. Then I'm going to say OA plus AP is equal to OP. Right? So OA is equal to A. AP is equal to, do we have AP? Yes, we have that. So half times B minus A, and that is OP, right? So now we can simplify this a little bit. So A, this is going to be half A plus B, I think. Can you simplify this? Half A plus B, and that is OP, right? So once you have OP, it's just a matter of putting it here. That's it. So OR is equal to gamma times OP. OP is going to be, so I'm going to put 2 here and then say A plus B. Done.